Hello, in this lesson, we will talk about LED, or light-emitting diodes. We will carry out a few simple projects using LED. Let's get started. What is LED? First, let's find out what a LED is. LED, also known as light-emitting diodes, are electronic components that convert electricity into light. LED have several advantages, including long lifespan, low energy consumption, and fast switching speeds. They also come in a variety of colors and sizes and can be used in many different applications such as car interiors, home lighting, computer screens, mobile phones, televisions, and many more devices. A diode, also called a semiconductor diode, is a two-terminal electronic component that allows current to flow primarily in one direction. An LED is a type of diode, so it also has a positive and negative terminals and it needs to be connected correctly. If it is connected incorrectly, it won't light up. Therefore, you should check that the LED are properly connected in the circuits we will be making. The terminals of an LED are often referred to as the anode and cathode, and usually the long pin is anode and the short pin is cathode. First, we will make a simple LED lighting application. The materials required for this are Arduino Uno, breadboard, LED, resistor, some cables. One more brief information. In an electrical circuit, a resistor is a passive component that resists the flow of electric current. Its purpose is to reduce the current flowing in a circuit and to regulate the voltage level. The resistance value is measured in ohms and it's represented by the Greek letter omega. In the example, we use a 220 ohm resistor to protect the Arduino pin because, if the LED draws too much current, it can damage the Arduino pin. Follow these steps sequentially. 1. Connect the cathode negative pin of the LED to the GND pin of the Arduino. 2. Connect one end of the resistor to the anode positive pin of the LED. 3. Connect the other end of the resistor to pin 5 of the Arduino. After carefully setting up our circuit, it's time to create our program. In this program, an LED by turning it on for 1 second and turning it off for 1 second. Before writing the program, it's important to break down what we want to do into smaller parts and think about it, otherwise, we will get lost in complex programs. Since we are going to start with a simple program, our job will be relatively easy. We want to blink an LED by turning it on for 1 second and turning it off for 1 second. We want to do this continuously, so we need to create a loop. This loop will repeatedly execute the actions inside it. Now, let's decide what the actions inside this loop will be. Loop will be: turn on the LED. Wait for 1 second. Turn off the LED. Wait for 1 second. Go back and repeat. As you can see, we have described the program in words. It will be easier to do it now. Now, let's create the algorithm we have defined with blocks. We must add a start condition to the beginning of the program. Right after, we need to add the loop command. Now let's add what the commands in this loop will be. First of all, we need to make the pin that our LED is connected to high. So we will give 5 volt DC to the LED from this pin and the LED will work. Then wait 1 second. Now let's make the pin low and turn off the LED. Then wait 1 second. That's it. The final version of our program will be as follows. Now let's upload the program to the Arduino. 1. Press connect. 2. First we check show all connectable devices, and then we press connect. 3. Now we are uploading the program. 4. That's it. As you can see, our circuit is working as we desired, and the LED movements perfectly match the algorithm. If you set up the algorithm correctly, the system will work properly. The most important aspect here is the algorithm. Now, let's move on to the next example. Buttons are devices that control the flow of electric current by opening and closing the circuit. When you press the button, the mechanism inside short-circuits the two sides of the contacts, allowing the current to flow. When you don't press the button, the spring mechanism inside returns to its previous position. In the previous project, we defined the Arduino pins as digital outputs, but in this project, we need to use the pins that we connect the buttons to as digital inputs because we will be making an input signal from here. When setting up our circuit, we need to position our button correctly on the breadboard, because the button's pins should not be shorted, otherwise, the button will have no function. In order to prevent this, we need to place the button in the center of the breadboard. We connect one pin of the button to the 5-volt pin of the Arduino, the other leg of the button is connected to the GND pin of the Arduino via a 10 kilo ohm resistor, and again this pin of the button is connected to the 12th pin of the Arduino. Note, the resistor prevents the input pin from receiving direct 5-volt, which can cause the input to work non-stability, hence a load is attached for more stable operation. This is an issue related to electronics, and for more information, it is recommended to research the pull-up and pull-down. Just as we learned in the previous project, we connect the LED with the help of a resistor to the 5th pin of the Arduino. Now we can move on to the programming part. First, I will talk about the if-else block, which we will use for the first time in this program. We should set up our algorithm with this logic. If-else block. The if-else block is a way to tell the computer, if something happens, do this, otherwise, do something else. For example, if it is sunny, play outside. Else if it is not sunny, read a book at home. This way, we can tell the computer what to do based on a situation. Another example. If you like apples, eat an apple. Else if you don't like apples, eat a banana. With this logic, we can give the computer two different instructions for two different situations. First, I start the Arduino program, then I set up a continuous loop because I want to constantly check the button. Now, if there is a signal on Arduino pin 12, I activate pin 5, otherwise, I do not activate pin 5. That's it, our program is ready. Let's upload it now. As you can see, I can turn on the LED by pressing the button. I am controlling an output using an input. RGB LED stands for red, green, and blue light emitting diode. It is a type of LED that has the ability to change colors. The RGB refers to the red, green, and blue colors, and by mixing these colors, a wide range of colors can be obtained. RGB LED are often used with control circuits, which allows the user to change colors and create effects. RGB LED are commonly used in lighting, visual effects, and other applications. RGB LED has 4-pin connection, they are common anode or cathode red green blue. Actually, an RGB LED is not much different from the LED we used in the previous project. It contains only 3 different colored 3 LED, and these LED are operated using a common anode or cathode connection. First, let's create our circuit. Our circuit has a very simple structure. The LED we will use is a common cathode RGB LED. Connect the common pin to the Arduino's GND pin, and connect the other pins to the Arduino's pins 4, 5, and 6, respectively. That's it, our circuit is ready. Now, let's move on to the programming part. First, we start our Arduino, then we create a loop. To change the colors of our LED sequentially, we activate the pins we use in sequence. First, we activate pin 4 and deactivate the others. Then, we activate pin 5 and deactivate the others. Next, we activate pin 6 and deactivate the others. Let's add a small delay between the sections in the program because we need to see the color transitions more clearly. That's it, we will see all the colors in order. Let's upload our program. You can see the transitions between the colors. Thank you for watching. See you in the next lessons.